advancement in technology have also made it possible to significantly improve mine safety. So one example is the use of drones to inspect mines, which can also reduce the need for human workers to enter dangerous areas. And you can see now almost all the mining companies, they are having drones, and they use it to inspect the mines. Now, it is easier for mines to be inspected and all that. And then the use of sensors can also be installed, throughout the mine to monitor the air quality and detect potential hazards. So we, as part of technology to, in underground mines, they have what we call a refuge chamber to support life in an irrespirable, atmosphere. Yeah, and then they also have virtual, reality training programs, which can also simulate hazardous scenarios and train workers on how to respond in a safe and efficient manner. And this type of training can be particularly useful for new employees who may not have experience working in the mine. So we have figure 9, refuge chamber, figure 10, virtual reality training simulator. So now, let's come to the terminologies. The first terminology we are coming to consider here is hazard. What is a hazard? A hazard is a potential source of harm or an adverse effect on people, property, or the environment. You see, hazards can arise from various factors, including physical, chemical, biological, and psychosocial elements present in the workplace. So there are various types of hazards that we can make mention. As I said, physical one. The physical ones are the rock falls, the noise, vibrations, heat, dust, and all that. Then the chemical hazards, we have the toxic gases like the carbon monoxides, the heavy metals, leaching into the nearby environment like lead, mercury, and all that. Then the biological hazards, we are talking about microbial, contamination, vector-borne diseases and all that. Sometimes in the pit, during rainy season, you see ponds of water. In underground, we say it's a swamp. But on surface, I don't know whether, but it can also be a swamp at the surface, pools of water, and all that on the surface, at the pit floor. You see, mosquitoes can use that as breeding grounds to, lay more eggs and then hatch them, and then they become more in the pond or in that particular water. So when workers go on night shift, maybe these stubborn mosquitoes can do justice to them, small. And then we have, as I said, we have psychosocial hazards. That also talks about the stress, fatigue in the workplace, and then isolation as well. So in mining, loose rocks, in underground mine can also pose a hazard by, potentially falling and injuring the workers and all that. So let's now move to risk. What is a risk? Risk refers to the likelihood of harm occurring due to the exposure to a hazard, combined with the severity of the potential consequences. So with risk, we can talk about likelihood. Likelihood simply means the probability that the hazard will cause harm. Then, still under risk, we can also talk about severity. You see, the severity talks about the potential impact or the consequences of the harm if it occurs. Still another risk, we can also make mention of another term that is called risk assessment. You see, risk assessment refers to the systematic process used to identify hazards, evaluate associated risk, and implement measures to mitigate or control those risks. So, for example, the risk of falling rocks in a mine depends on factors such as the frequency of rock fall, that is the likelihood, and then the potential injuries they could cause, that is the severity. Then let's come to occupational health. You see, occupational health also refers to the branch of public health which is focused on preventing and managing workplace-related illness and ensuring the physical and mental well-being of the employees. And the goals of occupational health is to protect workers from health risks associated with their job roles, and then to promote a healthy working environment, to also facilitate early detection and treatment of work-related illness. So with that, we can make mention of respiratory health. Protecting workers from diseases like silicosis, caused by dust, inhalation, and all that is very, very key in occupational health. And then with hearing health, also talks about preventing noise-induced hearing loss from prolonged exposure to loud machineries. And then the mental health too addresses stress, fatigue, and other psychosocial risk in high-pressure mining environment. Then now let's come to what we call occupational safety. Occupational safety also focuses on preventing workplace accidents and injuries by identifying hazards, assessing risk, and implementing control measures. So this emphasizes creating a safe working environment through systems, training, and protective equipment. And the goals of occupational health, occupational safety, is to reduce the incidence of accidents and injuries, and then to ensure compliance with safety regulations and standards, to foster a safety culture where workers prioritize safe behaviors and all that. Then let's now move on to rock falls. Rockfall. Rockfall refers to the sudden detachment and downward movement of rocks or debris from the mine walls, roofs, or slopes, typically occurring in underground or open pit mining operations. So that is that for rock falls. Then we will now move to machinery hazards. So machinery hazards are the risk associated with the use, operations, or maintenance of heavy equipment and machinery in mining operations. These hazards often stem from moving parts, mechanical failures, or operator errors. Examples of machinery, in mining, we have the haul truck, excavators, loaders, crushers, conveyor belt, and the rest. So the causes of machinery, hazards, some of them are mechanical, malfunctions due to inadequate maintenance, improper use of equipment or lack of operator training, poor visibility around large machineries, leading to collisions and all that. Then let's now move to the next terminology called noise and vibrations. You see, excessive, noise actually refers to excessive sound levels generated by machinery, blasting, drilling, or other mining operations that can harm hearing or reduce communication efficiency. Then for vibrations, it also talks about the oscillatory motion or movement caused by machinery, blasting, or ground movement that can impact both workers and structures. Both workers and structures. Then we have the next terminology also called dust. You see, dust in mining refers to the fine particulate matter generated during activities such as drilling, blasting, crushing, and materials handling. Dust can consist of various particles, including silica, coal, and other minerals. Let's move on to the next terminology called toxic gases. What are toxic gases? Toxic gases are harmful airborne substances that, when inhaled or absorbed by the body, can cause immediate or long-term health effects. These gases are common in mining environment and pose significant risk to the mining workers. Examples of such gases are the carbon monoxide, which is a colorless, odorless gas produced by incomplete combustion of fuels. And exposure can lead to, poisoning, unconsciousness, or death. So especially those of us who have an opportunity to work in underground mine environment, that worker should carry with him or her what you call the self-rescuer. The self-rescuer. Such that in case there is a release of this carbon monoxide gas, how will you see it? How will you know it? There is another equipment station underground called a stench gas. The stench gas will release its rotten egg smell into the system, such that you know. And once you have that smell, you should know that you are closer to your gone too soon area. So quickly you swing your self-rescuer to your front side, you nail, and then you don it. You don your self-rescuer. Once you don it, you move to the closest place of safety. That is the closest refuge chamber underground. You don't run whilst you have done the self-rescuer. You walk normally. But it can take you, the self-rescuer will supply you with fresh oxygen or oxygen that will last for an hour. So normally when you don it, you don't run, because if you run, you will be breathing faster. And instead of lasting for an hour, it may not last for that time. Then we have the hydrogen sulfide, that is H2S, which is also a highly toxic gas with a rotten egg smell, often found in sulfur-rich deposits or during blasting activities. It can cause respiratory distress or sudden death in high concentrations. Then we also have another toxic gas that is called nitrogen oxides, which is also produced during blasting activities or operations, and these gases irritate the respiratory system and can cause long-term lung damage. Long-term lung damage. So we should take notes of that. Then we have the other gases that we call them explosive gases. And explosive gases are combustible gases that can ignite or explode when mixed with air. in specific concentrations and exposed to a heat source. So these gases are a major hazard in mining operations, particularly underground. So examples of such explosive gases, we can make mention of the methane gas, that is CH4, commonly found in coal mines, which can form explosive mixtures with air, leading to devastating explosions if ignited. Then we can make mention of hydrogen gas, which can also accumulate in confined spaces and poses a risk of explosion during mining operations involving electrochemical processes. So we should take note of that. Then we also have the radon. And then radon is a radioactive gas naturally released from the decay of uranium, thorium, or radium in rocks and soils. It is colorless, odorless, and tasteless, making it difficult to detect without specialized equipment. So radon occurrence in the mining industry, it is normally found in underground uranium mines, as well as other mining environments where radioactive materials are present. Then it can also accumulate in poorly ventilated areas, which will increase exposure risk for workers. Then we have microbial contamination, which also refers to the presence and growth of harmful microorganisms such as bacteria, fungi, and viruses in mining environment. So this contamination often thrives in damp, poorly ventilated, or waterlogged areas. And their sources in the mining industry, one of them is stagnant water in mine shafts or tunnels, thereby providing a breeding ground for bacteria like Legionella, causing some diseases and all that. Then fungal spores from damp soil or rocks, such as histoplasma, which causes histoplasmolysis and all that. Then poor sanitation facilities can also lead to the spread of diseases like cholera or typhoid. So we should also take note of that.